Hello, my name is Bryan. I go to Homestead High School. I'm a rising junior. This is my main project, which is a CNC machine. My starter project was just assembling the kit. So most of the parts here were in a kit, and then I just added modifications onto it, and a lot of the program was learning how to use the machine to cut stuff. It was probably the hardest part, is figuring out all the software side of things. The hardware part, there were some challenges, but it was not nearly as difficult as learning how to get my computer interface with it. So the first thing I started out with was the kit, which had all these nice aluminum pieces and aluminum extrusions, which bolt together really easily. All you need is like some hex wrenches and then a 5/16 wrench, and you can pretty much build this machine. And it's completely solderless too. All the wiring is with terminal blocks that run to the controller that talks to the computer. And then the only thing that I had to solder was limit switches, so that when it hits the limit switches, it cuts off power to the machine so that it doesn't break anything. And then I have some other ones over here, but I haven't figured out how to mount them to like the Z axis to find a reliable way to get it to hit them and not cause a false reading. And then I had to get a fan because the drivers were overheating. It uses stepper motors to move it back and forth, and you tell code from the computer, sends it to here, and then the stepper motors move depending on what you're cutting. And then this right here is a spindle, or like a rotary tool that spins at 30,000 RPM, and it can cut through like light aluminum, brass, soft metals, and also hardwood like pine or oak. And then this board right here was a big challenge because I had to drill 144 holes and then tap each one of them so that I could make clamps to hold the material down so that it wouldn't move. That was like the biggest challenge. That took like 4 days of just sitting there with a hand drill, drilling holes day after day. That was the hardest mechanical challenge. And another thing is I realized I swapped this 90 degrees, so I had to flip it like the day before, on Monday. I had to flip this because I realized it wasn't working right, and that fixed a bunch of problems that I was having. Another thing is some of the modifications I made, which is a new threaded rod because the original threaded rod didn't have enough tolerances to get the precision I was looking for. And then I added a second motor to get it to make perfect circles when you move, because with one motor, the other side of the gantry sort of like drags behind, so you get like artifacts when you cut that wouldn't look perfect circles. So that was one of the challenges I had to deal with, and I made this much sturdier by adding a second bar to it, so that it could hold much more weight and prevent flex in the material. So that's it on the hardware side of things. On the software side, there's so many different open source solutions for talking to this Arduino and getting it to do stuff, but all of them don't work. They work sort of. They kind of work. You have to fiddle with them a lot to get them to do anything that you want them to. And so that was a really big challenge, is just finding software that would actually work with the machine the way it was intended. But once I found the software that worked, it made it really easy to go from having something in your head to actually start cutting it with the machine in maybe like an hour or two, depending on how simple the design was. And so after I figured out what software was, and I had to try like maybe 10 or 12 different types of software and like try to figure out how to use them before I figured out how to use the machine. And then after that, I managed to contact SolidWorks and some other big corporations and managed to get free trial software of their multi-$1,000 3D packages that would allow me to design much more complex parts for rockets. That's why I'm making this project, is to cut rocket parts and to cut like nose cones, centering rings, fins, and all that sort of stuff much more precisely than you could do by hand, and to make custom kits and that sort of thing, maybe sell them. So that was the main reason for this project. And I think that's everything. So without further ado, I'm just going to do a demo of all the axes moving, and it'll be a program that I've ran before. And then what it's what it would cut out if I had actual material there is the BlueStamp logo that I cut into this piece of plywood.
About how long would it take to do the thing you just?
Oh, and it would take, well, it's at 5% right now, and it's 30 seconds, so 5 times 30 times 20, so around 10 minutes, give or take. But we don't have to wait here. I can stop it pretty soon. I just wanted to show that it was working, and that it does actually function, and that I have completed it, my project. And then the stepper motor is, each of these are providing current to each stepper motor depending on how much they want to move or turn in either direction. And then you have to use these potentiometers on the board to adjust the current to make sure that it's not too high so that it wouldn't burn out the stepper motors, and that it's not too low that they won't be able to move because they don't have enough torque to actually move the machine. This is something else I also cut out, which had the circle problem I was talking about a little bit. It wasn't perfect. It was my first attempt at cutting parts for the centering ring to put in the body tube. And then, another thing I use for this project is I have a 3D printer at home. So some of the parts for joining this rail, I 3D printed parts that you basically push it in the center and it would hold it together. It was like an X clamp that you just push in and hold it together. And then I printed a thumb screw for moving the spindle up and down manually so that I can zero it out much more accurately than just turning this part right here. And then this I actually cut out of a cutting board, like this one, which is a mount for the much more powerful spindle. Because originally I had this Dremel tool that barely was able to do plywood, and it can't do much cutting, really. And that's it, really. I'll shut off the demo now. Any questions?
What was the most challenging aspect?
Well, in the first couple weeks, it was definitely drilling the holes and then getting it to actually move with, like getting it to actually cut stuff, because the code that I was generating was not perfect, so it would always sort of work and then something bad would happen. I'd have to figure out what was wrong. And most of the times it was the stepper motor didn't have enough current or the belts were too slack, so I had to tighten them. And another thing is the kit that I bought, some of the parts were really shoddy, and so some of the washers I had to file down to make them fit in the machine. And some of that, so the tolerances weren't the best. So when I bring this home, I'm going to probably take it apart and then build it again with better parts potentially.
How accurately can you make it sound?
Right now, the X and Y are pretty squared. So the only problem is the Z-axis, which has a bit of flex in the plate, as you can probably see. And so the Z is not the most accurate part. So if you're doing like lots of layers, where you need lots of detail across like a plane, it wouldn't be as accurate. But for just cutting out shapes, you can get like about 0.005 inches of repeatability. If you wanted to cut something over and over again, it won't differ about that much. Oh, Bryan.
So, 3D printing's in all the news. A lot of startup companies doing this right now, and a lot of them have been funded by big-time VCs for a lot of money. What do you think is the future of 3D printing?
Future 3D printing, using powerful lasers to melt the plastic together. Using lasers, and then some sort of subtractive thing, like this machine, for instance, but you mount it differently to cut. So you'd have something that would build a basic shape with laser and not extrusion, because extrusion is messy. But you'd have something build a basic shape that'd be solid within minutes, and then you'd have like some sort of cutter or subtractive machine that would cut away at it to add detail to the sides.
What about applications?
Applications, basically anything in engineering. So like if you wanted, they have bio 3D printers now, so you can print like tissue, organs, that sort of stuff. Parts, accurate parts, anything really. Anything that you can use that you have to design that's really specific, and there's not many ways to build it outside of machining it yourself or cutting it yourself.
Do you see yourself working with a 3D scanner, printer, and your CNC machine together and building something really cool stuff?
Yeah, I think they complement each other really well. So you get additive and subtractive manufacturing. So you can compensate for one's faults with the other. So you can make parts that are much stronger and sturdier out of aluminum with this machine. And then with the other machine, you can get parts that are really hard to make or design on a mill. And you can use those parts where they won't have as much load or but are still very important for like joining pieces together or for the mechanical workings of machines. Oh, it's a CNC machine, so it's a computer numerically controlled router, basically. Yeah, it's a router.